Welcome to my presentation. My name is TunaCapar and I'm an archaeologist who has an interest in the use of computer graphics in archaeology and cultural heritage, and especially lighting-based analysis within the discipline. This research has been derived from my master's project supervised by my professors Bernhard Eberhard from Stuttgart Media University and Haşmet Gürçay from Hacettepe University. There are different motivations behind the research, but our project mainly focused on the improvement of RTI analysis applied to material culture, in this case two types of artifacts, pottery shards and rock monuments. And for the first case, for pottery shards, but also to analyze small artifacts, we want to construct a low-cost RTI light dome. And as a result of these, we wanted to, of course, improve the visual enhancement of RTI. And since we had a light dome already built, we wanted to test out multiplex illumination to see if this could be a solution to be applied in RTI. But this is still a preliminary research topic, and our results are still initial. So reflectance transformation imaging, and in short RTI, is a reflectance imaging method and an extension of photometric stereo. So we take advantage of specially varying light sources placed around the scene or the object, and we take an image per light position from a static camera position. And since this camera position is static, it provides us a BRDF slice, and after getting the results, we're able to transform them, hence the name comes, and by doing that we can see the details that are not visible or easily visible to the naked human eye. And that's actually a great suit for archaeology and cultural heritage. For our low-cost light dome, I say low-cost, but to give numbers, maybe it's about €1,000, including a basic off-the-shelf DSLR camera. And it's equipped with 252 RGB LEDs, and they were manually soldered and daisy-chained before fitting inside the light dome. And we also spectrally measured them with a spectroradiometer in their individual RGB channels, amounting to 15,000 measurements in total. And the whole acquisition is done through an Arduino Uno board, so that runs the system. And it's totally automatic, and we can just, with one click, we can do a full RTI acquisition. And it's a high-resolution light dome because we wanted to distribute the light sources arbitrarily instead of putting them with specific angles and distances to each other. But we still wanted to sample the whole hemisphere, so we just increase the sampling resolution. And here's the light dome in action, which could be monitored with the computer screen outside. Culture has many different definitions. There is no specific definition, but for material culture, it's what we use in our everyday lives that is tangible, and these are the things that humans produced and interacted with. And archaeology actually deals with material culture to understand past human societies. So this could be a nice-looking Roman theater, as the one here, and small artifacts such as pottery shards, which will be the basis of this study. Pottery shards in archaeology are analyzed in two main topics. The first one being surface properties and decorations of the object. These are colors, impressions, even damages on the object and fire patterns, and they indicate us about the use of the objects and the message that they carried. The second one is the inclusions in the clay, and these point us about the structure of the object itself, like if it's a coarse ware or fine ware, and the source of the clay. But of course, archaeometrical analysis are providing extra information in that regard. The documentation of pottery in the early years of archaeology, not only for pottery but for many other object types, were done by sketching and painting, which I call the sketching and painting phase, because due to limited access to technological instruments. And then came the technical drawing phase, which provides us information about sections of the pottery and so on. But these are totally technical and do not provide information such as color and so on. And for that, of course, we need to take high quality images, and today is the high quality imaging phase. And this can be, of course, extended to like laser scanning, structure from motion, and so on. But all these phases, they actually lack one specific information, that is lighting. So at least in imaging phase, in last phase, what we see in the photo is always a static lighting, and in this case the fidelity is lost. For instance, here is a pottery sherd taken from a 2018 excavation report, and with this resolution, and the authors are saying that there is a bullhead, relief of a bullhead, which is actually traceable, but still it's not giving so much information, and the human material interaction is totally lost, and our interpretations are based on what is said by the researchers, excavators themselves, and this condenses everything into a subjective evaluation of pottery sherds, which is contrary to what archaeology is. And actually archaeology is about visual analysis of the material culture, and computer graphics and archaeology come together in that regard. For our research, we chose 2 pottery sherds as our samples, but this could be extended, of course. The first one is an impressed pottery sherd with preserving 4 finger marks, as I can show here, which is not really visible, but that's the whole point. And the other one also has carvings on the surface, but we chose this one to exemplify the inclusions in it. So in the first case, we have the ground truth image, and after getting the RTI acquisition, we can also see the finger marks. We think that they are finger marks, and of course the bumps derived from the inclusions in the clay. And here in specular enhancement mode, we can see all the details much more better. So regarding the question of if there are finger marks, we wanted to take a close-up look, still with RTI, and there are no fingerprints preserved, so which tells us that this could have been made with an object, or the fingers were covered with a material. As for the second pottery sherd, and with RTI actually we can also see the details on the surface, but if you look at the inclusions, the close-up image, we can see, for instance, here is some holes on the sherd, and normally these pottery sherds may include lime and chaff, and during firing in the ovens they actually burn out and leave such pores on the object. And also the reflective elements on the object came more visible. For instance, here there is one inclusion that is not visible, and so on. And we shouldn't forget that this is just one of the renders out of thousands. So we are able to see much more details in the inclusions of the pottery sherds. Our second example was immovable tangible heritage. In this case we have chosen rock monuments. They're mostly placed in, found in really challenging outdoor environments, and that was the case with this object here. And they're always under the risk of destruction, human factors, weather, and so on, so they have to be recorded anyway. In RTI, in this case, RTI was a good solution to see the details, carving details on this object. Since we have always an ambient light, if you're lucky, we don't have, of course, direct sunlight, but ambient light is always in the scene. We wanted to improve the acquisition by removing the ambient light from the object. So for this case, we did our traditional RTI approach, freeform RTI approach, by placing a manual light source around the object and taking an image. But just immediately afterwards, we took an image without the flashlight and just with the ambient light. So we subtracted the second one from the first one, and we obtained a difference image which shows so many details, and as if the object was taken at night. Of course, going there and taking the object, acquiring the object, these images at night is a solution, but it's really challenging. In this case, I don't see that it's doable at all. So we process all the images from the first acquisition, ambient light plus flashlight, and get our estimated normal map, and also process the difference images and get our estimated normal map as well. And the comparison would bring so much details in the second case. So the object is totally readable, visible, and that's actually improvement itself by removing the ambient light. And if you look at the specular enhancement mode, these are with the same settings, of course, and we can also see the details, and in the carvings, in the cartouche here in front of the king's head, we can see the depth information and so on, and everything is much more preserved, of course. Lastly, we wanted to test out multiplex illumination using our light dome, and this is the idea of using simultaneously lit multiple light sources to illuminate a scene. therefore increasing the scene irradiance, and the advantage is the reduction of dynamic range, exposure times, as well as improvement of signal to noise ratio. The light patterns are based on S matrices, and these are derived from Hadamard patterns. It's a square matrix having only the values of -1 and +1. And then inverse S matrices are used to reconstruct single images. So as a result, it looks like as if the scene was illuminated with a single light source only, but with improved results. So a Hadamard pattern would look like this, and black and white squares represent lights turned on or off at the same time, but having the same values is irrelevant. Therefore, we cross these first row and column out, and then we're left with an S matrix. In this case, that was an N3 8x8 matrix reduced to 7x7 matrix, and ones represent light values turned on, LED sources turned on, and zeros represent turned off. But the basic requirement for multiplex illumination is having two light sources. Therefore, we wanted to test this out on our highly reflective chrome sphere from a single given direction. So we took our images, 3 images, and then we reconstructed them. And in comparison to the ground truth image, we can already see that the dynamic range is decreased. However, if you look at in detail to the highlights, and due to our close proximity of light sources to each other, there are some artifacts in the reconstruction. For this reason, we wanted to distribute our light sources inside the hemisphere, inside the dome, this time using 7 light sources turned on at the same time. As we can see in the resulting demultiplexed image, we already have details in the shadowed part, which would be normally all black, and the highlights are preserved well. But this is due to the distribution of the light sources. And we tested this with an object which has a relief on its surface, and we can already see that reconstruction is well and the highlights are preserved. But again, we wanted to test this with our pottery shirt, again with a single direction of illumination with close proximity of light sources with 4 LEDs. And the inclusions in the clay would be less reflective than the chrome sphere, and our demultiplex result actually showed us the opposite, and we don't have good highlight reconstruction in this case as well. So for higher number of N, so this was tried with N2 and N3, but we can increase this for the whole hemisphere inside the light dome, and we always have close proximity of light sources to each other, which is a question mark how it should be done. To sum everything up, so we can conclude that low-cost RTI dome is totally doable and is suggested for archaeology, because for instance in our pottery shirts it took us only 20 minutes to generate our results, so 10 minutes for acquisition and another 10 minutes for post-processing. And in the traditional terms, doing this technical documentation and taking images actually is taking longer, so that's already an improvement in our results. And of course, this subjective evaluation turned into an objective evaluation, and it's digitally reproducible and shareable, and that's what it should be like. In the case of outdoor scenes, we totally suggest that ambient light removal should be done. Of course, we can go there at night, but it always preserves dangers, so ambient light removal should be the result in this case, in our opinion. And multiplex illumination is still an open question, but we can already conclude from the rock monument case is that the reduction of dynamic range actually gave us worse results, so maybe multiplex illumination is not really suited for RTI, but still this has to be tested in future studies. So that was all. I want to thank you for your participation, and we would like to thank to these people. And if you have any questions, comments, or anything to say about our presentation, please drop me an email in the following email address. Thank you and all the best.